Alright everyone, Cody Don here. Welcome back to my laboratory. So, a little while ago I made a video trying to show that if you are underground you can hear thunder through the earth before you can through the air because sound travels faster through rock than it does through most gases. And I was a little successful, however, due to the unpredictability and rareness of thunderstorms, I really didn't get to try again with a better microphone. So today I'm going to try something else. Introducing Thunder in a Can. Are you doing experiments with lightning and or thunder and are annoyed by the random and unpredictability of it? Well, Thunder in a Can is for you. Thanks to our patented magic boom powder, the acoustic energy of a lightning strike can be released at any time and location that you choose.
Thunder in a can is extremely unsafe, therefore it is not legal to transport or distribute. It is further banned for public use in many states and most countries. This is a joke, not an actual product.
So yeah, I'm gonna make my own thunder. Okay, so the can is buried, just the very top of it is exposed now. I'm going to put a bag of flour over top of it so it puts up a nice white cloud for us to see on camera. Got everything wired up. Now I'm just going to go half a mile away. Okay, let's turn this one on. Okay. So here I am, underground. I've got about 50 meters of rock above my head. There's my Yeti microphone nuzzled right up against the stone wall there. Got my laptop here recording both video and the audio from that microphone. Let me actually just sync the audios. Okay. Sure that's still recording. Good to go. I guess I'm gonna head on out. A lot of muck that needs to be done in here. It's quite a hike actually. We go. Daylight. Washing out the sensor. Let's turn that back down. So to help keep the air blast from getting to the camera underground, I've got this foam pad here that I'm going to stuff over the entrance. Hopefully that helps. Yeah, it's a little harder getting up there above ground. You gotta go up the hill. Okay, so this pile of rocks here marks where the end of that tunnel is. 50 meters straight down. Set the camera up. The boom's gonna happen right about there. Alright, you ready? Fire in the hole! 3, 2, 1. That worked! Perfect. So, results time. You just saw what this camera picked up from above ground. Now I'm going to show you what the underground camera recorded. A little haunting, isn't it? Now I'm going to combine the audio from underground with the audio and video from above ground. 2, 1. From that, you can clearly hear the thunder through the ground before you can through the air. I mean, through the air it takes a little over 2 seconds to travel the 715 meters, so that's about 350 meters per second. But through the ground it travels only about 6 or 7 frames of video. And I was filming at 60 frames per second, so that's something in excess of 6 kilometers per second. Like 14 or 15 times faster than the sound traveled through the air. Like, that's kind of crazy, isn't it? So why does the sound travel faster through the ground than the air? Many people may try to tell you that it's due to density.
But if that were true, helium would make your voice deep, which is clearly not the case.
The speed of sound is actually determined by how fast something can respond to being pushed. For a gas, that is basically how fast the gas is moving on average, which is determined by the temperature and mass of each individual particle. A solid material has chemical bonds holding the particles together, and the stronger those bonds and the lighter the particles, the faster the speed of sound. It's kind of like taking a rubber band. A tightly stretched rubber band will have a much faster transverse wave velocity than a limp rubber band does. This is why materials such as beryllium and diamond have such high speed of sound. They have light particles and strong bonds. The same goes for rock. One more thing I'd like to point out, especially if you got headphones on, you'll notice that the sound is not a single boom. It's more of a boom boom. Or, a boom and then a smaller boom shortly after. So what you're hearing is the primary and secondary waves coming through. The primary wave is basically just bumping the microphone, kind of like that. And the secondary wave is shaking things around a little bit more. In this case, we picked up the primary wave a little bit better because the microphone was, up against the rock, and the secondary wave would have moved like this, which wouldn't have transferred very much energy to the mic. Plus, the thunder was producing mainly a pressure wave. The secondary transverse motion was just, there wasn't very much of that generated. The gap between the two wave fronts is like 5 or 6 frames, which indicates that the secondary wave travels about half as fast. This property of seismic waves is what allows us to calculate the distance to an earthquake. If I would have set off the thunder closer, the gap would have been smaller. Now someone might say that the second wave front that comes through might actually be a reflection or an echo. Well, I actually took steps to avoid that. You see, the rock layers were originally laid down like this, but in the past 500 million years have been tilted up to almost vertical. And I placed the thunder can on the same rock unit. It is true that the seismic energy can reflect off of the different rock units, but with it set up like that, they're just going to bounce back and forth, kind of like light down a fiber optic cable, therefore focusing the energy and directing it to my microphone. Which I did very intentionally to stack the cards in my favor. If I would have done it so that the seismic energy had to go through the rock layers, it would have caused reflections, and every time it reflects it loses energy, and it might not have been enough to even be picked up because, well, that microphone's just not made for this kind of thing. So, hope you learned something. I'll see you next time. Thought you guys might like to see the crater. There it is. A little bit wider than the hole I originally dug. Let's see, there's some paper. There's the wire. That looks good. You know what? I think I'm going to plant a tree right there. I think that'd be cool. I guess that's one way to loosen up the soil.